So here's a quick video to show how to set up the Scopy environment for your project. So some of you will be doing a hysteresis width of 600 millivolts, and the way you adjust it, given that our resistances are fixed, is with the power supply. And so on my setup with my op amp, positive 4 volts and minus 3.7, when I come over to the oscilloscope, will give me 0.3 and 0.3. And really, within 10%, it is good. Now, I have links to this one. So the STOP37 hysteresis width of 600 mil, that should set it up. Now the thing is more than likely you will have to adjust these to get it into that system. And the group that's doing 400 millivolts hysteresis width is 3 and 2.6. And if we come over to the oscilloscope, that should be giving us 0.21. All right. So on each side, so that's 420, which is within 10%. So those two files are in the lab manual. Sorry. Trying to find. Okay. So if we go to the end, all right, the group assignments are here, and these are the nominal power supplies. You might have to adjust it to get the nominal hysteresis width. Now, what I put down for forcing functioning amplitudes, 50, 100, 200, it all depends on how many group members you have. And if like let's say you had 3 group members, maybe 50 and 100 don't work, so you do 2, 3, and 4. If you have 5, you do all of them, right? And then there's your frequency. Here's your Schmidt trigger INI file, right? And when you go and do your other one, then you should, when you go to measure things, that's when you got to read in your the noise file and keep it at 50 kilohertz, right? Sample rate or samples per second, right? And make sure that these don't get changed if you happen to read in a new file. But here's the verification, right? And so things that you need, what should be in your report, an LT Spice schematic showing you, a sample circuit, right? Just one, not, all the changes you made. With the Python results. Then tables 1 and 2 filled out from the previous section, except now with your data and everybody's data together. All right, trying to get it like the paper. All right, and we can work on that, a sample diagram, a sample Python code, so that you can have more than one data set. All right, you could have more than one theta, right, and then plot it all on the same plot, but then have a legend that shows whose data it is. So if there was 3 people in the group, right, there'd be 3 of these plots, 3 of these plots, and hopefully they're lining up pretty well, right? Then so you have to put in these plots and then extract this equation, right? And imagine the barrier heights and this constant here won't be exactly the same. All right. The team assignments are here, and all the links today are Dropbox links, and so you can see who the TA and who the groups. Some people just came in kind of last second, which is fine because some of the groups were kind of small, so here's your TA assignments. Yazdi gracefully said she'll take 2 teams. I just put the frequencies there again. But again, just a standard report, oral presentation. You can do it in Google Slides. It's easy to collaborate that way. I think what I can also show is some sample, excuse me, they put their names, what they did, who it was, who your TA was. What is stochastic resonance? A picture. Now here's the thing, everyone will have a different circuit, so maybe you can have a picture of everybody's circuit, right, with a name to it, right? One plot, right? These results. Now these are slightly different than I presented this year. Use the ones I have in the lab manual, right? But this is just one kind of sample plot. This one will have everybody's data on it, and it'll be with the signal to noise ratio. This presented like this. No, put the signal to noise ratio here, and this one after that slide. All right. And then, here's, different V peak to peaks. Something weird was going on. We couldn't get the signal to noise ratio down below. Wouldn't really go down. It's nice to have the data, but you can put a link to your data, right, that people can download, right? Then I can actually download it. But that might not be so necessary. And then a conclusion slide. Really, we're talking about 10 minutes, 15 tops, and it's more like an update rather than, a full, like it's your final senior project. All right? And, it's all good. We're not being graded. This is fun. We're just learning. So really, don't sweat it, right? Do the best you can, because, of course, I'll be using you as a role model of excellence when we do this next year. Okay? So that's it. Good, happy hunting.